Hi everyone, I'm Shivani and this is my project, which is called Science Behind Food Preservation. There are various methods of food preservation which I'm going to be discussing in this presentation, including pickling, salting, smoking, canning, pasteurization, refrigeration, dehydration, lyophilization, high osmotic pressure, cheese making, chemical preservatives, antioxidants, and radiation. Pickling involves putting foods like fruits, vegetables, and meat and preserving them in vinegar. Harmful microbial growth is arrested by an action of acetic acid, which is basically vinegar. In salting, foods such as fish, lemons can be preserved in salt. Salt prevents microbial growth on these foods. In smoking, this treatment of fish and meat prevents spoilage by dehydration. The smoke produced from burning certain woods contains some compounds, some of which kill bacteria. In canning, food contents are processed and sealed in an airtight container at a high temperature. It's used for foods like meat, fish, fruits, and vegetables. Fruits, lemons, and tomatoes with a pH of less than 4.6 are all canned by boiling water in canning method. Different varieties of tomatoes are dependent on its stage of ripening have pH of about 4.6, so it is acidified by adding vinegars like acetic acid or organic apple cider, and then it can be boiling water. For milk at pH 7 and vegetables like beets, potatoes, green beans, and meats having the pH ranging from 4.6 and 7, pressure canning preserves them. Cucumbers have pH in this range too, but they can be acidified with vinegar and acetic acid using a tested recipe of pickling, and then can be preserved by boiling water, canning method. In pasteurization, this involves heating liquids at high temperatures for a short amount of time. Pasteurization kills harmful microbes in milk without affecting the taste or nutritional value. This makes sure milk is safe to drink by killing any bacteria and also helps to prolong shelf life. The process of pasteurization involves heating milk to 71.7 degrees Celsius for at least 15 seconds and no more than 25 seconds. Once the milk has been heated, it is then cooled very quickly to less than 3 degrees Celsius. There are two methods of pasteurization: low temperature long time, which is LTLT, and high temperature short time, which is HTST. Refrigeration involves perishable foods like milk, meat, fruits, and vegetables, which are stored at 4 degrees Celsius in a refrigerator. Frozen temperature is approximately negative 18 degrees Celsius, which is good for storing longer periods. Deep freezes at negative 60 degrees Celsius are good for storing meats and fish for long periods. They work by slowing down growth of bacteria. Dehydration. Removal of water from foods prevents microbial growth and enzyme activity. Many fish and fruits are preserved by this method. High osmotic pressure. By the principle of osmotic jams, jellies and pickles are preserved. Water is withdrawn from microbial cells when they are placed in solutions containing large amounts of dissolved substances such as sugar or salt. As a result of this water loss, microbial metabolism is halted. In lyophilization, it involves rapid freezing and then dehydration of the frozen product under the vacuum, useful for storing, transporting, and preserving food in bacterial cultures. In this process, fresh or cooked food are flash frozen and then placed in vacuum chambers. Around 98% of the food moisture is drawn by evaporating the ice at temperatures as low as negative 50 degrees Fahrenheit. Freeze-dried food is sealed in moisture and oxygen-proof packaging, ensuring freshness. When ready to use, water is replaced, and the food regains its original fresh flavor, aroma, and texture. In cheese making, there are 6 simple steps in cheese making: acidifying, coagulation, separating curds and whey, salting, shaping, and ripening. While the method for making different cheeses vary, the following 6 steps outline the basic processes of turning milk into cheese. Acidification. Startle culture is added to milk to change lactose, milk sugar, into lactic acid. This process changes the acidity level of the milk. Coagulation. Rennet is added to ensure the milk to solidify. Curds and whey. Curds are cut using a curd knife and a curd rake. Cutting the curds encourages them to release whey. The smaller the curds are cut, the harder the cheese will be. The larger the cut, the softer the cheese will be. Salting. Salt adds flavor and also acts as a preservative. It slows the cultures and enzymes down and can also help a natural rind to form on a cheese. There are several ways to use salt. Salt can be added directly into the curd, or the curd can be brined. The outside of the veal of cheese can be rubbed with salt or with a damp cloth that has been soaked in brine. Shaping. The curd is put into hoops to form its shape. The curd can also be pressed with weights in the hoops that will expel more whey. Ripening or maturing. This process ages cheeses until it reaches optimal ripeness. During this process, the temperature and humidity need to be monitored. During the maturation process, some will develop a rind, for example, a bloomy white mold or blue cheeses. They must be turned while maturing. Some must be brushed with oil and some must be washed with brevlinens, brine, or alcohol. Chemical preservatives deal with chemical and microbial spoilage. Antimicrobial preservatives like nitrates, sulfates, benzoates, and sorbates respond differently to different microorganisms. Potassium sorbate. Its mechanism is quite complex, involving different antimicrobial activities at different sites of the microorganisms. It works by inhibiting Krebs cycle, an electron change function in microorganisms required for metabolism. This is done by slowing down formation of central substrates such as glucose and pyruvate required for Krebs cycle for energy production in microorganisms to survive. Potassium sorbate also affects bacterial and yeast spore survival cycle. By acting on spore membrane, it completely alters the permeability of spore membrane, thus making them much more susceptible to surrounding environment, resulting in cell lysis and death. Besides, potassium sorbate also inhibits protease, enzyme crucial for spore germination into microbes. Just like this, there are other antimicrobial preservatives inhibiting growth of microbes in a variety of different ways. These are commonly used in conjunction with one another to eliminate or minimize risk of food spoilage. Stopping oxidation in foods. When cut foods are exposed to oxygen and air, many compounds lose their electrons to oxygen molecule or free oxygen radicals, forming bonds with them. Oxidation is a destructive process and causes loss of color, flavor, and nutritional value in foods. For example, when an apple is cut, phenolase, a naturally occurring enzyme in its cell, acts as a catalyst in oxidation of amino acid tyrosine found in the plant cells. The final product is melanin, which is dark brown in color, which we can see in apple browning. To interrupt this process, there are two choices: either deactivate phenolase enzyme or eliminate the oxygen entirely. In some foods, enzyme activity can be seized by denaturing enzymes by blanching, acidifying, pasteurizing, or irradiating. Enzyme activity can also be slowed by refrigeration of freezing of foods. Removing oxygen by airtight vacuum packaging, or by modifying atmosphere by injecting inert gas like nitrogen in food packages. Antioxidants. These are another kind of preservatives which slow down natural oxidation of fats and oils in foods. Double bonds in unsaturated fatty acids that are found in fats and oils eventually become oxidized, releasing volatile aldehydes and ketones. These functional groups are the cause of rancidity, such as foul odor and flavors in these foods. Antioxidants can inhibit oxidation by using both free O radicals and O2 molecules before they react with double bonds of fatty acid molecules. This delays the natural oxidation process. There is a concern of public health from adding these chemical preservatives to food. However, intensive studies conducted have found that if consumed in moderate amounts, dietary exposure to these is well below the level that cause any noticeable health issues. Finally, there is a minimal risk with balanced diet, which includes some of these common preservatives. Food irradiation. It is the process of exposing food and food packaging to ionizing radiation such as gamma rays, X-rays. Radiation kill microorganisms on food surface. By choosing the right wavelengths and dosage, the rays can prevent sprouting in vegetables like potatoes and maintain their freshness and taste. It destroys harmful bacteria in spices, meat, and seafood. They can also rid fresh fruits and vegetables of insects in their eggs, which might otherwise hitchhike and spread with transport of produce to other regions of the world. The beam of electrons shown on food packages has an intense intensity to give desired effect. It is this cold process, so spices retain their unique flavor and aromas that would be diminished by heating. It avoids reliance on chemical methods like fumigation and pesticides to combat bacteria, insects, and other spoilage organisms. The food packaging also undergoes treatment, hence irradiating beams pass through packaging, so food is protected longer and remains fresh longer. That was the end of the presentation.